This is a James Webb Space Telescope that was launched about 10, 11 days ago. I got into astronomy 5, 6 years ago. I pretty much watch films almost every night on this stuff. So I'm really into this, and I thought I'd share some of this stuff with you guys. So we all know about the Hubble Space Telescope that's been in operation now for 30 years. We've all seen the stunning images from Hubble. And Hubble has its limitations. It can only look so far, etc. This telescope is a real game changer. If you're not into astronomy, I understand, but just follow this along the next few months and you'll see what I'm talking about. So what does the next generation look like? First off, if you look at this mirror right here, that's folded up right now, but it's going to be 6 times the size of Hubble. And that gives this telescope 100 times farther range, which is a real game changer in astronomy. That mirror, by the way, is going to be 21 feet high. And that shield you see that protects us from the sun is the size of a tennis court. Okay, so I'm going to turn on my camera. And if you look in the background, can you see the image behind me?
Let me stop sharing. I'm going to pin you for our guys here. Go ahead.
Okay, so that's the telescope actually folded up, and sent into space in this rocket. And when it's in space, it actually unfolds itself like origami. Very, very complex process. Takes about a month. And then once it reaches L2, which is its optimum range, 1 million miles from Earth, that's when it's fully optimized, calibrated. It's going to start taking images. It's going to take about 6 months. What are we going to see? What is this telescope going to show us that Hubble was not able to do? Obviously, 100 times the range, so you can look further out. But more importantly, this telescope is going to capture infrared light, which is invisible, and Hubble does not have that capability. And what does infrared light mean? It's basically the early light that was generated by the universe almost 13.5 billion years ago. So think of this as a time machine. The images we will see in 6 months, if everything works out, is really going to be looking at our past. What did the universe look like 13.5 billion years ago? It's kind of hard to conceive that, but that's what this is going to do. The other exciting thing that this is going to track, this telescope, is going to be what they call exoplanets. So planets outside our solar system that are very similar to Earth. You can't zoom in and actually look at a planet. The distances are so vast. But they're looking for biosignatures. Basically, all that tells you is the atmosphere of the planet. Does it have any water vapor? Does it have carbon dioxide, methane, things that Earth generates? And, so you can track that from space. Same thing we're looking for in other planets. If you find one of those planets, then the next step is to focus on that, and then hopefully in, 40, 50 years, even try and send a probe over there. So it's, for astronomy geeks like me, this is very exciting. And so look for this in 6 months for images just like Hubble, maybe in late July, when this is fully optimized and it's operating. So I'm very excited about it. This is something it's been a real passion of mine. And so I thought I'd share it with all of you.